Let's look at a program that toggles all bits of port 1 continuously, and a set of 8 LEDs are connected to the port 1 such that the anode of the LED is connected to the port pin. And when we toggle the bits of port 1, the LEDs will blink, that is, they will turn on and off alternately. Now, since the LEDs are connected such that the anode is connected to the port pin, the LED will turn on when a logic 1 appears at the port pin. So when the value of port 1 is equal to FF, all LEDs will become on, and when the value is 00, all the LEDs will be turned off. So according to the connection, we should send FF to turn on the LEDs and 00 to turn off the LEDs. Now let's look at the program. Let's copy the value FFH into the accumulator. The instruction for that would be move A comma hash 0 FFH. Then we will send the accumulator content to port 1. Move P1 comma A. We will copy the contents of the accumulator to port 1. Now the contents of port 1 becomes FFH. This will cause all the LEDs to turn on. Next we will call a delay subroutine which generates a small delay so that the LEDs become visible. The on and off operation of the LEDs become visible to us. So a call delay will call a small delay. This delay subroutine you can write either using the timer or you can use a software delay. Next, after the delay we will complement the accumulator so that if the value was FF, it now becomes 00. If the value was 00, it becomes FF. So when we first execute the program, the content of the accumulator would become 00. And then we jump to repeat, where repeat is the label of the instruction which copies the contents of the accumulator to port 1. So the accumulator now contains 00 that will be copied to port 1. So when the value at port 1 is 00H, all the LEDs will turn off. So when this program is, and again we will call delay, which will provide a small delay, again complement the accumulator and continuously repeat these steps such that we get a square wave on all the port pins of port 1. If we look at the waveform at each of the port pins, it will be a square wave of 50% duty cycle, and that is the same as toggling all bits of port 1. And if we look at the LEDs, they will turn on and off continuously. This will be continuously running. The program will turn on and off the LED continuously. So I hope you understood the program. This is very easy. The only difference between this program and our previous programs where we generated a square wave is that in that case we were considering only a port pin. A square wave was generated on a single pin. But in this case, an entire port is toggling. All the 8 bits of the port will be toggling. There will be 8 different square waves at each of the port pins. And if we connect LEDs as shown in the figure, the effect will be, we will get a set of 8 LEDs blinking. That is, they will turn on and off alternately. So if you have any doubts, please call me and clear your doubts. Thank you.